Hello, my name is Colt Davis. Thank you for coming to my presentation on comparing growth rates and maturity between different species of Nenue in Oahu, Hawaii. The objectives of my study were to compare age and length relationships between Kyphosis hawaiiensis and Kyphosis vigensis. Also, I wanted to compare L50 of each species. This is the length at which half of the individuals in a species reach sexual maturity and are able to reproduce. In Hawaii, non-commercial fishing on nearshore reefs provide more than 7 million meals a year. Worldwide, over 6 million people rely on coral reef fisheries for their livelihood. This underscores the importance of fisheries management in coastal communities. It's important to find the length that a fish reaches sexual maturity. We don't want too many fish being caught before they have a chance to reproduce. This could cause a fish stock to start falling. The length at which 50% of the population reaches maturity is commonly used in fisheries management as a minimum size allowed to catch a fish. This ensures that enough of the individuals are able to reproduce and keep the fishery sustainable. However, in Hawaii, we have a few species where we do not know their maturity and there is no minimum size for them to be caught. Nenue are nearshore reef fish that are found in Hawaii. There are 5 species around Oahu, and currently we do not know when any of them reach sexual maturity. However, the fishing regulations allow them to be caught with no minimum size. My study looks at 2 of the species, Kyphosis hawaiiensis and Kyphosis vigensis. Most of the Nenue used in this study were provided by lab personnel and volunteers spearfishing on the windward side of Oahu. This figure shows the study area for most of these fish. They were caught off of Mokumanu near Kaneohe and down by Manana Island in Waimanalo. Now, we didn't catch all of the fish used. Some of them were also purchased at local markets. 2 markets that we would use were Tamashiro and Chinatown Marketplace located in Honolulu. Once we got the sample into our lab, we would have to identify the species using meristic traits such as fin counts. On the top right photo, you can see we're counting the soft fin rays on the dorsal fin, and we also counted them on the anal fin. The different species would have a different number of soft fins for each one of those. Then we would take their fork lengths and we would remove their gonads to determine their maturity. The gonads would go to another lab who would return them to us stained on slide so we could check their oocyte development. We also removed otoliths, which are these small ear bones located in the fish's head. We would grind and mount them onto slides so we could count their annuli and see how old they are. So the gonad slides are returned to us stained and dyed so that we can see the sexual development. The top picture shows a mature male. We know that it's mature because the sperm have tails. They don't have tails, and that leads us to believe that they're immature. The bottom picture shows a couple different stages of oocyte development in females. Depending on how they look, you can see if the fish has reached maturity or not. We can actually tell if it's actively spawning, if it's developing, if it just spawned, and recovering or regressing. So you can get a lot of maturity information through these gonad histologies. This is what an otolith looks like when it's been ground down completely. As you can see, the annuli lines, you count them, and just like a tree ring, it tells you how old the fish is in years. So this is 2 graphs showing the relationship between age and length of males and females for each species. On the left we have hawaiiensis, and on the right we have vigensis. So on the left you can see that both male and female have very similar growth rates throughout. And on the right for vigensis, you can see that females, after around 5 years or so, start to grow at a longer and quicker rate than the males. This graph shows the growth curves of both species together so we can compare them. So on the x-axis I have age, on the y-axis I have length in millimeters. Now you can see that up until around 5 years of age, they have very similar growth curves. They're pretty overlapping. However, after 5 years of age, vigensis look like they're growing larger and quicker, and they have a higher growth curve. These two graphs are showing the percentage mature compared to the length. So on the x-axis, I have the total length in millimeters, and on the y-axis, you have the proportion mature. So ideally, there would have been some data points right in the middle around 0.5, which would give us our L50, or 50% mature at that length. Now, when I was running this through, I got an L50 at 97% confidence interval at 268 millimeters for Colposis hawaiiensis. For Vigensis, the L50 for 97% confidence interval, I got 284 millimeters. Now this is over 10 inches for each of these species. Vigensis is a little bit bigger, but each one of these is over 10 inches. So currently, if this was accurate, our current regulations allow this fish to be harvested no minimum size. But it might be a fact that they don't reach maturity until 10 inches. However, they probably reach maturity under 10 inches. There are some issues with my study. For instance, I don't think I have enough data, so I'll go over this now. Now, when I say I need more data, what I mean is that I need more samples. I needed more Nenue. I needed more of them that have overlapping lengths of immature and mature. This is important to get an L50. So I also just needed more samples in general. I only had around 32 samples for each species, and ideally I would have at least triple that. The last batch of slides that I received was actually this week, just a few days ago. So I haven't done all of the statistical analysis I need to account for my low amount of samples. I'd like to give a special acknowledgement to Poseidon Fisheries Research, where I did perform my internship. Thank you, John Wiley and Cassie Pardee. Here are some references used throughout my presentation. Thank you for coming and have a wonderful evening.